So now that I've given you an overview of Java structured concurrency, I want to talk about how to program Java's structured concurrency mechanisms. And we'll see that there's a couple different ways to do this, all of which have been added recently into Java 19. So first thing to remember is that Java structured concurrency is still evolving. It's not settled yet. And so some things that were there even in Java 18 have changed a bit. They've added new stuff. They've changed some method names. And that's why you can only run this stuff with the preview features enabled. And there's all kinds of warnings that say, preview, preview, warning, warning, you're using a preview feature, it could change. So it's great for teaching purposes, but just be aware that as Java matures and we get to Java 20, some of these APIs may change a bit. Although I doubt that they'll radically change at this point, but who knows. There's two different ways you can do structured concurrency in modern Java, very, very modern Java, Java 19 and beyond. And the first one involves a new set of methods in the executors utility class and a new set of methods in the ExecutorService class and a few other things that are related to that. And so the first thing we're going to look at is this very, very verbose method called newVirtualThreadPerTaskExecutor, which is quite a mouthful and makes me cringe when I have to write slides with this because I have to reformat my slides in crazy ways. And you can see also the links I give at the bottom of the page are starting to get into like 8-point font to try to fit on the page. The newVirtualThreadPerTaskExecutor feature is used in conjunction with a Java try with resources feature. So again, this is something that's been around for a while in Java. And what happens here is when this method is called on the executors utility class, it returns an ExecutorService instance, which we call executor here. And that executor will be closed and cleaned up and joined when the scope exits. And you can see the scope is defined by the open curly brace, close curly brace. So basically, we're creating a new executor that starts a new virtual thread for each task. And that's what's different about newVirtualThreadPerTaskExecutor. It doesn't work with a pool of threads. It makes a new Java virtual thread for each task. And you can see here that we do this by using the ExecutorSubmit method. So ExecutorSubmit's been around for a long time, since Java 5. And it basically says, take this callable, which in this particular example is super simple. It's just going to go ahead and sleep for a certain amount of time. And it says, go ahead and create a new virtual thread to run this thing. And you can see we're going to create a large number of them. We're going to create 10,000. Although, if you recall the example we looked at before when we were talking about virtual threads, 10,000 is a drop in the bucket. You can have 10 million virtual threads if you have enough memory on your machine quite easily. So we're going to go ahead and submit 10,000 we're going to create 10,000 virtual threads that will essentially sleep for a second and then return. The downside with this approach, and why it's kind of being sunset or deprecated is too strong a word, it's being ignored in the documentation for Java 19, is it's a bit limiting. And that's because we have to have everything cleaned up implicitly by the time the scope exits. And we'll see that there's another feature we're about to talk about, which is StructuredTaskScope, that does not have that limitation. It's a bit more explicit about where you want the barrier to be. This barrier is very syntactically cool, but it leads to some awkward programming. So, because of this, the very, very, very latest stuff that's coming out in Java 19 adds in this StructuredTaskScope class and some subclasses. It's really kind of a little mini framework if you think about it. And this allows you to split things up into little chunks by forking, and it gives you more control over the lifetime of when those forked virtual threads have to be completed before you can continue in the scope. Now, the StructuredTaskScope stuff is also used with the try with resources feature, just like the ExecutorService stuff we saw, except there's a couple new names. So you make a new StructuredTaskScope shutdown on failure instance. So shutdown on failure is a class that's nested inside of StructuredTaskScope, and you can read more about what semantics are here, but basically it's a vehicle for spawning virtual threads and then joining them and then reporting errors if something goes wrong. So as you can see here, what we're going to do is we're going to go ahead and use this scope object, which is of type shutdown on failure, to fork two new tasks. And when we fork, of course, that'll spawn a virtual thread each time. And we're going to go ahead and find a user, and we're going to fetch an order. So we're going to let those two things go on in parallel. And then when we know that we need to get a result, because we can't go any further until we get a result, we can use join. And what join does is it waits for all the threads to finish the task scope, or it shuts things down. If an error goes, if things go awry, then it'll go ahead and shut down. And we can also throw an exception if something went wrong. So that's how we report errors. If something went wrong inside here, throw a fail, we'll throw an exception. Otherwise, it's just a no-op. And then the last thing we do here is kind of interesting. So we're going to make a new response object, whatever that might be, and we're going to give it the results of finding the user and the results of fetching the order. And to do this, we're going to use a new API that's been added into the future API. This is the class, the interface future that we've known about for a long time. And what it's going to do is it's called result now. And result now basically, it's kind of like get without having to do checked exceptions in quite the same way and without having to check for certain things. This will give us a result. If we know that the results are done, result now will just return the result, which is often a very useful thing to have, useful feature to have. So we're going to get the results. And we know that this is going to return results because we wouldn't have gotten here if join hadn't noted that these threads were done and if throw a fail had thrown an exception. If that had happened, we wouldn't be in this piece of that block of code. So the other thing to note is at the very end of all this stuff, when we go out of scope of this try with resources block, the scope variable will be cleaned up automatically and closed using the auto close feature of try with resources. So let me just give a quick assessment of this. So this is kind of cool, sort of, and it's designed to try to make concurrent programming have a bit more structure to it. And there's also a belief that this approach is going to obviate the need for asynchronous programming. So a lot of the stuff we talked about when we talked about things like completable futures, a lot of the stuff we talked about with respect to reactive programming, supposedly structured concurrency is going to make all this go away. But there are a few problems. And the biggest problem I see so far, and I don't understand for the life of me why they did this. Well, I sort of understand, but I think it was a big mistake. They use future as the vehicle for keeping track of these asynchronously computing computations, operations, which is a botch in my mind. And that's because future, as you know, has all these limitations. And there's a bunch of things you cannot do with structured concurrency that you can trivially do with things like completable futures or reactive features like RxJava or Project Reactor. In particular, one thing that would be nice would be to say, spawn a bunch of virtual threads and then have a way to wait for the first one to finish. So you could do this kind of, invoke any-like approach. Or you could say, spawn a bunch of completable futures and take when 2 of them finish or n of them finish. But all they give you is basically, sort of invoke all, where you invoke everything and then you get the result back and they all have to finish. So there's no way of being able to do the more sophisticated kind of completion stage method processing that you get with completable futures. And I think that was a horrible botch. Now, I think the reason they did that was because they were trying to keep it, quote, simple. But as is often the case, when people try to do something simple, they often do something that's simple-minded. And then you find yourself having to do crazy stuff to make up for that. So in my mind, the structured concurrency style of programming in Java as it exists at the moment is really only useful for embarrassingly parallel programs where you have kind of a co-begin, co-end-like model, where you start off a bunch of threads, and then you wait for them all to finish, and then you go ahead and give a result back for that. So it's not really that useful, and it doesn't replace the need for the more powerful forms of concurrency that we've taken a look at, like completable futures or reactive programming. Even though you'll hear lots of people claiming that it does. I don't think people have enough experience with it yet to really understand the limitations. Okay, so that's the end of the overview of how to program Java structured concurrency.